Okay, so you see my screen, yes?
Yes.
Okay, let me start. Okay, let's first explain what we are going to talk. First of all, thank you for inviting me in your wonderful community to give a presentation. I think it's really important to share knowledge to everyone who is interested in engineering field. And I'm really glad to make my presentation. So my presentation will be about breaking up Monolith into microservices, what challenges, why we need to do this, and what advantages and disadvantages of this. Okay, let's just start a little bit about me. So Irina already introduced me, but let me do this again. So I'm Oleg, I'm a software engineer. I have about 10 plus years of experience and financial organization, mostly in fintech and banks. And I did a lot of different roles, engineering, leading, architect. You could find me on LinkedIn and GitHub. Okay, enough from me. Okay, our agenda would be like this. So first we are going to talk about Monolith, challenges of Monolith, how we can solve the problems with Monolith using microservices architecture, and what problems we have with microservices architecture. And in the end, we will have session for questions and answers. You could write your questions in the chat during the presentation, but I'm not going to read this during presentation. I'm going to read them at the end. So, but you could just write to not forget anything you wanted to ask. Okay, so let's first start with Monolith. So what is Monolith? First of all, Monolith, it is, in most cases, it is one repository. So which means you have one Git repository where all your source code is situated. Whenever you need to change any small things, you need to make pull request in your repository, ask somebody from your team to approve it, and you merge it. And another important thing, what this Monolith is, it is one build. So it means that when you need to build some artifact, so you have only one artifact, you can't split it on several parts, so you can't roll out to production partially. You could roll out to production only one particular artifact. And of course, if it's one artifact, you have only one deployment. So which means in production, you have one deployment, and whenever you need to change something, very small one, you need to roll out to production with your big artifact. So this is definition of Monolith. And of course, you tightly coupled with particular stack, which means, let's say, if you wrote your service in Java, so most probably you can't change it. So you can't use Java and, let's say, Go or PHP or Python or any other languages. Eventually, you can do this, but in most cases, you can't. And most probably you have one big database where all the data is situated, and all the components of your services has access to the data. And this kind of definition of Monolith. Okay, let's look into this example, what it is. Let's say you are writing e-commerce store. So let's say you have a customers, so you need store some information about customers in the database. You have products, so customers could find different products. They see pictures of the products, description of the products, and they could put those products into their car, into the basket, and eventually they could do purchases. And all this logic is stated in one service. All the information is stated in one database, and it perfectly works fine. But what could go wrong? Let's say you, as an engineer, you need to always remember that you support business. So business brings the money to the company. They think about different features. They're saying, we need that feature. This feature brings money to the company. And you need to make those features very fast. If you don't make those features fast, your rivals could do this faster, and which means that they could get your customers, which means your company will lose money. If your company loses money, you eventually will have layoffs. So we don't want layoffs. So in that case, we want to make features faster, and our complexity of our logic is growing with the time. So which means we need more features, more logic, and we need to roll out everything in production faster than our rivals. Okay, and what could go wrong here? So with growing business, we need more engineers, which means we need more teams. And those teams and engineers need to negotiate with each other how to support and implement this feature in one particular repository, how to roll out this to production, how and more people, which means that development will be slowed down because there will be some collisions. Somebody should decide to refactor something, or somebody needs to have approval. So with more people, it will be harder to support your service. And another problems will arise as rollback in production. Let's say somebody makes some wrong decision in the code. He introduced some bug into their component. This will be allowed to production. And if it's bug, it should be rolled back. And it means if it's monolith, you can't roll back partially. You could roll back everything all at once, and somebody's feature could be rolled back. So it's very painful in production environment. And also another problem is how to support this. So let's say you have monitoring, dashboards, you have alerts, and it's not obvious who is responsible for what in the production. And of course, another thing is how to split responsibilities in your big sources. Okay, so those are problems that could arise with development if you have one monolith and a lot of engineers that make a lot of changes in one repository and need to support one particular monolith. Okay, let's look into example. As we have our same e-commerce site, we have all the logic, and we have a lot of engineers that support this service. So how we could simplify this? How we could simplify our development? We could split our big service into small microservices, and each individual team could support their service. They could make changes independently. They could roll out it anytime. They have their own databases. They don't intersect with each other. It will be easy to support this. The only thing you should care about is how those services are communicating with each other. Okay, so let's say we split our monolith on smaller microservices, but let's say our business is saying that we need to add new feature. Let's say for our product component, they needed to add features for feedbacks. Let's say customers, so they want that customers could give feedback on each product. So let's say they bought something, they try it, and they want to share feedback, and you added the feature in your product component. Your component became bigger. It's hard, and another team. There are two teams that supports your component, and it's again we have the same problem with negotiation with each other, and it's harder to support. And in that case, you could split your let's say microservices that become big. You could split it on two additional microservices, on two microservices that have their independent databases, independent logic, and teams that are responsible for that microservices. So it seems like it's very easy, but it's not. So you can't just take and split monolith into microservices. So because there are some problems, and let's think about that problems. Just give you an example. So some well-known companies, Netflix, Amazon, Twitter, PayPal, etc. They are very big companies. They have a lot of customers. And at the beginning, when they just started, they had a monolithic architecture. And in order to grow faster than their rivals, or at least grow somehow, because with complexity, it's harder to support the system, they needed to split their monolithic architecture into microservices. And could you guess how fast they made it? So they made it in years. So let's say, for example, Amazon started to split their monolithic architecture, let's say in 2010, and completed in 2015. So they required about 5 years to split their monolithic architecture. So it's very tough process. In my experience, from my current company and previous company, we split monolithic architecture, let's say in 1 year. So it's a very tough process because it requires some you need to split logic from your monolith. You need rollout to production, route traffic from your monolithic architecture to your microservices. If it's some problems, you need to spot these problems. You need to change your logic in the microservices, roll out again, and repeat this process again until you made your microservices that could be completely separated from your monolithic architecture. So just for example, so is it this how it looks like microservice architecture of Amazon? So each particular square, it is microservice, and a line between each other, it is how they communicate with each other. So it's like it's about thousands of microservices in Amazon. So that's given us idea why they took so long to split their architecture. Okay, we could split this on microservices, but what is it microservices? So microservices is loosely coupled services, so which means whenever you need to do changes in one service, there is no impact on other services. So you could do the things independently in each component. Of course, if you change API between microservices, so other teams should know about the changes, and so it's not like a completely independent, but if you don't change API, it is completely independent, and you have independent teams that are responsible for that, and you have independent builds, and you have API how microservices communicate with each other. And about communication, so there are different types of communication: synchronous, asynchronous. So synchronous means that if you send a request to one service, you need to wait for you're waiting for the response from that service. Asynchronous means that you don't wait for response; you just send to topic or queue, and any number of subscribers could get the information from the topic. So, and this, I think, one of the important things when when you split monolith to microservice architecture, you need to provide API. So this API should be described, and this is one of the great problems of how to split microservices. Another thing is how the services should be roll out to the production, and most probably you're going to use containerization. So what does it mean? It means that each services will be run in Docker container. So Docker container is lightweight version of virtualization, and if you have 1,000 of Docker containers, so you need somehow orchestrate them, and for that you're going to use Kubernetes, which allows you to roll out microservices with one command, and you need probably infrastructure teams that will be responsible for everything, for supporting your infrastructure. And there are a lot of problems that arise with that. So supporting infrastructure, communication between microservices, and how you monitor everything in the production. Okay, so if microservices are so good architecture, so why you don't just start everything with microservices? And it's kind of a reasonable question. So why you don't just start it? Why all these companies, Amazon, Netflix, they just started with monolithic, and why they didn't start with microservices architecture? And the answer for this is that when you do monolithic architecture and it's just you just started, it will be easy to support at the beginning. If you start with microservice architecture, you you'll spend a lot of time on building your architecture, and you need to the team should know how to build this. The team should be very experienced in building microservice architecture. So let's say at the beginning, it's easy to start with monolithic architecture. When your system is growing, it becomes harder to support it. And at some point, you need to decide to migrate to microservice architecture, because eventually you can't support it, because it will be a nightmare to support a big monolithic architecture in production because of the incidents and other problems that could arise. So let's say start with monolith. At some point, you need to split it and support microservices. Okay, but let's say whether microservices are so good, maybe in some cases monolith architecture is much better than microservice architecture. And if you try to Google something related to the topic, just recently Amazon announced some topics that they they reduced cost by 90%, introducing monolithic architecture in their infrastructure. So this topic just arose recently. If you could find it easily in the Google and find the original article, but actually, if you look into details of that article, you see that they're talking about they realized that distributed approach wasn't bringing a lot of benefits in our specific use case, so we packed all the components into a single process. So they're talking about specific case and specific process in their architecture. So they're not talking about combining all the microservices into one big monolith and support it, because it will be impossible. So they're talking about only on specific use case. So why they did this? Because they have some services, and between those services, they send a lot of video traffic, and it's too much overhead because they have a lot of customers who view a lot of videos, and it makes sense to maybe combine some of the services into one in their particular use case. But it doesn't say that they're going to give up on microservice architecture. So it seems like even if you see such topics, it doesn't mean that they're giving up on monolithic. It means that only in specific cases they're going to give up on microservice architecture. Okay, to sum up, monolith architecture is very good for proof of concept. So proof of concept means that you don't know the result of your services yet, but you just need to prove that it works somehow, and it's really good for a start. And monolith architecture is hard to scale. It's harder to maintain, and we could solve it by introducing microservices architecture, which is easily scalable, because you could just increase number of your services in production by using Kubernetes command, just increase number for that particular service. And with microservice architecture, it is easy to make time to market features, which means you could beat your rivals and eventually your company will survive. But as a downside, we have communications overhead in our architecture. So that's what I wanted to share with you. So if you have any questions, please ask me. Let me read in the chat if I have any questions. Yeah, so let me find anything. Yeah, so questions, yeah, you could write any questions anytime. Yeah, that's, I don't know if you see what I'm sharing.
Yeah, you sharing your presentation with the questions.
Okay.
So
okay.
yeah.
Let me read the questions. I avoid AWS step function as they are super expensive. They're good. There are good use case for them.
That was regarding the Prime Video one. You put the latest. Can you hear me?
Yes, I hear you well. Yes.
Yes. So that is in context. When you were talking about that page, I was like, yeah. It seems like they are anti microservices, but And they did this cost saving because they were using serverless, and in particular, the AWS step functions, which is quite expensive. And we also avoid it because it's quite expensive. There are many ways to like develop your microservices. So I think they ditched AWS step functions, which is why they got that cost optimizations.
Yeah,
Really not about microservices is what I was trying to get at.
Yeah, so most probably so they just save the cost by removing unnecessary communication between their step function and put it in into one service. But nevertheless, they still using microservice architecture in general way. But in some cases, yes, it makes sense. Yes, thank you for the comment. Is micro enough to balance the communication between teams for cross-cutting features with independence of change? Do you agree that more teams, more communication, regardless of your architecture? There are different ways how to make how to understand the size of the microservices. For example, if you take into example the same Amazon, so that they are saying one team should be the number of teams should be enough to consume 2 pizzas. Let's say it would be like say maybe 6-7 people, and each team should be responsible for several microservices. In my experience, as a team is responsible for one team responsible for 5 or up to 6 microservices, and based on these numbers, you could figure out somehow whether this service is big enough or it requires some modification. But it's not only about the size. Another thing you need to consider is whether you make changes actively in your particular service. If you make a lot of changes and there are a lot of teams that make changes in that services, then it's a really good candidate for splitting. But if it's big, you don't change it at all, it works fine in production, you don't have problems, maybe you could keep it. So the most important thing is how you're going to save the cost in the future. So I would say that there is no like one answer for that question, but so it depends. If it's hard to support, it's time to split it. And yeah.
I was going to say thank you for that insight. I think one of the challenges that I'm seeing is a system that's already set up as microservices. Whenever a new feature comes in, it touches so many of them. And the way that we split up the work is very squad focused. It's entirely possible that some of the work required for that feature will slip through the cracks, and getting that idea of everything being in place for the feature and being able to confirm that is a trick by itself. So even if we've split it up too small, we can end up fragmenting.
Yes, exactly.
In the attempt to get small changes out quickly, which is another heuristic we use.
Yeah, of course, you don't need to split a microservice to small enough things. So the size should be reasonable. If you see that you split too many microservices, it will be too much overhead between communication with them, between supporting those microservices. Yeah, so don't split just constantly on the smallest thing. So yeah, and it's hard to say where's the border between microservices and micro microservices. So it's based on experience you could figure out. So it's a good idea to split by domains. Let's say if in our example we had domain for user, for client information, domain for products, and domain for orders, then yeah, it's good to split them, but don't split into small microservices.
Oleg, I'd like to just add on that question there. So it's a very good question. And where do you split basically is the question you should be asking yourself. Would you need to scale it separately? So if there are requests coming in, would it make sense to make it into a microservice so it can scale exponentially without having to scale the rest of the system that's not used? And that is like a good enough, that if you ask that question yourself, you will know whether you will have to scale, how much do you scale?
Yes, that's a good approach for scaling. If it's one component in service requires scaling, then you could separate it and use it as a separate microservices. Another approach is to think about what's critical flow, what's not critical flow. You also could separate all the critical flows into separate microservices, and non-critical you could keep it in one big kind of microservice. I see the raising hand.
Yeah, I want to add here that I think you didn't mention domain-driven design, which is actually should be foundation of splitting services to microservices. Like everything should be at the same domain, at the same place. And the feature required changes in a lot of things. Probably the main design wasn't right. Or another point that it also could be that you change something which is core thing, like user model, right? That model actually affects almost every service in your system. If you change this core model, it's really the truth that you need to change every single microservice, because every single microservice uses user model, for example. Or another super core part of your system, for example, in financials, it could be the model of transaction. If you change model of transactions, unfortunately, you can't say like, okay, Monolith could be better. I could just change everything in one repository, do like replace, and then you've done. But now you have every single team that's responsible for their product apply these changes that actually appeared in this transaction model, but because transaction is a model that go across the whole system. And in this case, I would say, okay, that's normal. Still, transaction itself separate core domain, and all other products have their own domains. And the goal here is that if you have some domains that can be separated, it should be separated as much as possible, but should be at the same time everything in one domain. That's my thoughts about it.
Yeah, I agree. So they could be just absolutely independent. So if you, let's say, change API, so other services could be affected, and you need notify other teams that uses your service, that consume data from your service or call your service. Yes, I agree. So it could be 100% independent, but at least if some changes that not requires drastic change, you could make them independently. But in some cases, there is some overhead between communication. I see another raised hand from Tess.
I just wanted to ask how many people were using things like API contract versioning and model versioning to ease the rollout of these things, because some teams won't be able to roll out changes to, say, a transaction model at the same speed as others. So that might be one way of doing it. I don't know whether other people have different solutions for that problem.
If you're talking about changing API, I'm not sure about the question. So we're talking about how many people required to support API?
No, I think it's about versioning. Like, for example, if you don't have versioning and have everything in snapshots in your company, you change something in core library and everyone just get in the next moment this new updated library. And then everyone has compilation broken in their services. Then you have to definitely. But another approach, another approach that you could have versioning, like, and here is trade-off. If you have versioning for everything, then every single changes, you wait for feedback from every single team. You wait for them, apply this version, see if it works for them. If it doesn't work, you change it.
Yeah, I agree. So it's it's two different approaches, and most probably whenever you change you make changes for the API, you're trying to do that in that way so you don't have impact on other. For example, if you add new fields, so you could make these fields non-required. So let's say if it's like could be like a nullable and non-mandatory field. So you're trying to do such kind of changes, and you do version and you roll out your new API, let's say, into production, and other services could eventually, they could just update it without doing synchronized update of all the services. So,
but the question is, in your company, for example, do you have to issue a new version every time? Like every single version is new version. So to apply these changes, another team should lift up their Gradle build.
Yeah, so whenever we do changes to API, we make new version, but we are trying to do this in that way so we don't have impact. So let's say we add a new field, so we don't make drastic change. Let's say we don't completely redesign API. We mostly add in new fields, and we do these fields non-mandatory. For example, we're using in some teams using gRPC proto format, and some fields you could put these fields as a non-mandatory, and if it's not field, so it's okay. So and
yeah, but the question here then appeared because you're actually talking about splitting monolith to microservices. In this case, it would be always changes in API greater than just add new field, right? If you're moving from microservices or from monolith to microservices, then like the question also, what is faster? Just to decline versioning and do snapshots, because then the feedback will be just in 1 minute, and as a teammate from another department come to you and say like, okay, this change actually will broke my service. Or
from my experience, I think it's better to use versioning all the time. And if you're doing something that is some drastic change, you try to notify, synchronize with other teams, but it happens very rarely. In most cases, whenever you change something, it's some small changes. You don't have too much impact on other teams. So yeah, so I would prefer to have versioning than to have snapshots from my experience, because with snapshots you don't know with which version you compiled your downstream services, and
with latest, always with latest.
Let's say you compile with latest version, but then they again changing something, and you don't know which version you used. So you could find by snapshot, but it becomes too much of a pet.
You always have the latest version.
If you're
the approach
talking about
here for non-compatible change, some changes still will be non-compatible, and I hope it will also answer the question. Like, it could be hybrid approach. So you have sometimes big version and then declare it as a BOM file. So then you switch a BOM file like in infrastructure. And in this case, you can do these incompatible changes, but still leaving the snapshots. That's another hybrid approach that I can share here.
Yeah, another way is to have some file of dependencies, and you add, you put all the versions into the one big version library, and whenever you updated your API, you change this API version into the big dependency jar library, and whenever somebody needs to update, they just update that big library, and they have automatically new API. Okay, I see another raised hand.
I just wanted to check, when we're talking about a BOM, are we talking about Java World?
JVM, JVM world.
Yeah,
it could be Java, Kotlin, Scala.
Got you. Thank you.
Okay, very nice discussion. Okay, let me read another. Step function, state machine to. Okay, that's related. On the road from monolith to distribute microservices, how different should your testing strategy, B, test boundaries, etc.? Yeah, that's a really interesting question. So first of all, you need to test everything as before. You use modular tests, and also you need to, in some cases, it's you need to apply integration tests. In some cases, so if you could apply pyramid of testing. So let's say on the basis there is a modular test that is the biggest one. So it means you need to write as much as possible unit test. Next layer is smaller a little bit. It is integration test, which means you need to start some resources in order to test the service. And at the end, there are small type of tests called end-to-end tests, which check all the infrastructure. And I prefer to support to use that way. So use triangle structure. So most of the modular tests and integration tests and in the end-to-end tests. Okay, how actually you find borders between services to put them in different microservice sets? Interesting question. So the easiest way is to split by domains. So let's say it will be dictated by the structure of your organization. If the team knows that domain, they're responsible for that. So it's a good idea to split your, let's say you have several teams, each team has their domain knowledge. It's better to split your service into those domains. It will be much easier because the team's responsible for a specific domain. In some cases, it's hard to find who is responsible, and eventually, even in current situation, we have situation when some services has responsibility of other services, and in that case, we need to think about how to do re-architecture. So it always will be the problem whenever you split on different domains. It always will be the problem how to think where you should put that particular feature into that service or into another service, or you could make another separate service. Okay, so I see questions from Rajani.
Yeah, so I just wanted to add to that. There are, like you said, domain is a very good and a classic way of doing it, but there are other ways as well, like a single responsibility principle where you said they are loosely coupled, and how can you like this is a responsibility of this microservice, and this basically handles this functionality, right? So if you can design it as a single responsibility, then that's a nice way to do it. Sometimes it's also based on data communication.
Mm-hmm.
So yeah, there are many ways, and like you said, putting it based on the domain makes sense. But I think the next strongest one is the single responsibility principle.
Yes, so there are different ways to do this, and it depends on your organization. What is better for the team? What is better for the company? It's better to choose your specific approach in your particular case. So there is no like a silver bullet. That there is no explanation for all the type of the cases. So it depends on the organization. Have you used AWS Fargate for microservices? Would you recommend this option? For my story, I've never used AWS Fargate. Maybe anyone else in the chat is used. Maybe you could share, but I've never used it.
I can. So AWS Fargate is nothing but it's a compute unit. It's the same as having an EC2, but just serverless.
Mm-hmm.
So it is the infrastructure, right? It's I know you're talking about microservices, but if you had like a Docker that you wanted to deploy in the AWS Fargate, and this Docker was your microservice, then yes. But AWS Fargate is just a means to the end. Your microservices can sit on AWS Fargate. Equally, it can also sit on the EC2s in your AWS. I don't know, Maria, if that helped answer your question. But yeah, I'm an evangelist for AWS serverless. So because there's less maintenance and everything is automated, so I would say AWS Fargate over EC2 anytime. But there are, anytime, yeah.
Yeah, thank you, Rajani, for your comments.
Sorry, because there was a comment about the cost of AWS step functions. So I was just wondering, we're kind of trying to decide between using step functions and multiple, or just one single.
You've just got to you've got to work. So the AWS got a cost calculator, so you just got to use it, and sometimes it's not even about cost, it's what really works, what really fits your application, and where is it. So if you ask me, if yours doesn't need to be a long-running application and is not gathering data, needs to be run for hours on end, I would just say use AWS Lambda, for example, right? And you have schedules on AWS Lambda, which sometimes the AWS step functions, you can get away with AWS step functions by using schedule lambdas and event-driven architecture. So I can't comment without knowing the exact scenario, but I'm just saying that you may also look at Lambda, because you only run a Lambda for what it's required and it's only built for that. And it may turn out cost effective compared to running a Fargate, which internally is running on a compute even at 24/7.
Thank you, Rajani. I see questions from Tess.
I was going to chime in with some of the decisions that we've made around Fargate versus EC2 versus Lambdas. We had to look at things like the cold start, how we could integrate the security for Fargate versus EC2 versus the Lambda. The other thing I'd say about step functions is we tend to use them when we have an offline process. So we're waiting for a human who's handling a human queue of checking and then coming back on an application. So it's not a case of waiting microseconds for something to complete through the state machine. It could be a few days, or we're waiting for an end user action that comes back within 21 days or something like that. So that kind of workflow seems to make these step functions more palatable from a financial position. But for a regular turnaround of asynchronous functions that we expect to be fully automated, it's probably overkill for most people.
Okay.
Yeah. And I just want to, on the topic of AWS Lambda and cold starts, you could keep the states pre-processed. So when a Lambda starts, you basically are not, you can just swiftly take it, read it from an S3, AWS parameter store, wherever it makes sense. And then you can actually kickstart your Lambda really quickly. And there are ways to get around the cold start. And the newer versions of Lambda have a snap start, which resolves the cold start problems. Just putting it in there.
Okay, thank you. Okay, let me read. Sometime backward compatibility, supporting all previous version of Aliens. Okay, that I think related. Okay.
I think you skipped one question there. What is your take on microservices for low latency applications? Because if you split things out too much, or even if you split things, and if it's a low latency application, you have to consider the cost of communication, right? The TCP/IP at the end of it. So what is your take on microservices and low latency applications?
Do you mean that services should respond very fastly, so they shouldn't wait too much time on responses? What's the question about?
Yeah. So literally, when you say BAM, it is the lowest, and any data, like literally ticking by the seconds, it loses its it loses its value with every second or millisecond that goes past.
It depends. So you should take into account latency. If it's too much, if you on each call you lose too much latency, so let's say then yeah, you need to think about to combine some microservices. But let's say in payment world, let's say we have a request from Visa, and we should respond. Let's say when you let me give you an example. When you buy something with your physical card, Visa, MasterCard, or any other card, usually scheme provider, it's Visa or MasterCard, they're saying that issuer should respond within 5 seconds, and 5 seconds it's enough time to make a lot of calls to different microservices. Usually we respond, let's say, less than 100 milliseconds. And in that case, we don't have too much problems with those latency. But yeah, I would say in other cases, when you get market data, so it's very important. In that case, architecture should be very reliable for that case. Let's say maybe you don't need to use HTTP calls. Maybe you need to build sockets and send everything in particular in duplex channels. So it depends. So it depends on the use case. So
one of the things we do actually to avoid these, every socket connection, right? You said sockets. I mean, even if you go down to the level of TCP/IP, a socket connection is costly at the end of it. So what we do is we do connection pooling and try and avoid. So we already prepare these connections. So then we're only talking about the data being transferred. So yeah, I
yes.
just wanted to see if you had come across,
for example, for example, if you're using gRPC, so it establishes connection. So whenever you make a request to any other service, it doesn't establish connectivity once again and again. It just established connectivity, and it uses duplex channel, which means whenever you send data, you don't wait for response. You could send another request, and you could receive response independently. So let's say if using gRPC, it uses HTTP2, which means it established channel, and it's established socket communication, and it's very fast for communication between services. So it depends. If you need very low latency, so it requires some modification in your infrastructure. So it depends.
Thank you.
What is URI versioning?
It was on the topic of versioning. So I was just saying that for APIs, we use URI versioning, and database, it gets even more complicated, but yeah, that's what we do.
Yeah, so
yeah,
maybe
I think we covered everything.
I think we covered everything. Thank you so much. Okay, Ira, over to you.